We will be talking about Chapter 3 this afternoon. This is the second video, and in this video, we'll look at how to add two vectors or more together using trig. So, every vector can be thought of as the hypotenuse of a right triangle. It's maybe easier to understand this if we draw it out, but if you have a vector that is at some sort of an angle, if in your mind you visualize that as the hypotenuse of the right triangle, then you'll have a horizontal component and a vertical component. So maybe, well, no, let's move along. So let's remember what is the hypotenuse. I know you know, but we're going to refresh your memory. So here we have our right triangle, and in this little lower corner is the angle theta. So the hypotenuse for a right triangle is always the longest side, and then opposite and adjacent are picked based on where is theta. So if we pick theta to be this little angle in the right-hand corner, then the side opposite that is over here. So that's the opposite side. The one that's not the longest side and not opposite, but just next to the angle is the adjacent side. So adjacent is the side next to the angle, opposite is the one directly across. And I know you've had some trig, and you remember that sine is opposite over hypotenuse, that cosine is adjacent over hypotenuse, and that tangent is sine over cosine. So that means it's opposite over adjacent. Another thing you probably remember from right triangles is the Pythagorean theorem that a squared plus b squared gives you c squared. So if you know two of the three sides of a right triangle, you can calculate the length of the third side. And this will be important for us. So if c squared is equal to a squared plus b squared, then c is equal to the square root of that. Now, most of you are accustomed to writing the square root like we have here at the end with the radical sign. But in physics, a lot of times what we do is we take what you would stick inside the radical, so a squared plus b squared, and we put it in parentheses or brackets, and then raise it to the 1/2 power. When you raise something to the 1/2 power, that is the same as taking the square root. So you can use the little caret symbol, the little upside down V on your calculators when we're dealing with this, or you can take square roots or whatever. But I'm probably always going to write it this way. All right, so let's move along. To add two or more vectors by components, first thing you have to do is break each vector up into its parts, into its components. What do I mean by that? I mean, if you think of a vector as being the hypotenuse of a right triangle, what we need to know is what is A and what is B. We want the parts that make it up. All right, so I'll show you how to do that. And then what you do is add the individual horizontal components to find the total horizontal. And then you add the individual vertical components to find the total vertical. And then we use trig to find the resultant. So again, if you know A and B, you can find C. So we're going to take the little parts to make the A and B for the big triangle. And then use trig to come up with also the magnitude and the direction. So we'll need to know how big and which way. All right, so as an example, we're going to use the exact same vectors from the graphing example. Vector 1 was 160 meters per second at 22 degrees north of east, and vector 2 was 120 meters per second at 67 degrees north of west. And this requires a lot of paper, so you'll need to provide your own paper for this. I didn't leave you blanks in the notes. First thing we do is sketch the vector. So we're going to resolve vector 1, which to remind us is 160 meters per second at 22 degrees north of east, into components. So to do that, because it says north of east, I only drew in the north and the east part of the north, south, east, west coordinate system. I only drew in part of it, north and east. And then, because we said the vector could be considered the hypotenuse of a right triangle, I went ahead and put in an x part, which has to be pointing east, because east is the direction we were given. So the red dashed arrow is pointing east. That is the x component of vector 1. So v with a sub 1x. And the reason it points east is because east was one of the directions we were given in the coordinates. It doesn't really matter how big it is, it matters which way does it point. The y component has to point north because that's the direction we were given. So vectors are added head to tail. So I drew east in. Now I'm going to draw the one going north. And again, it'll point north. So that's v1y, the y component of the v1 vector. And then we said, okay, the v1 vector is the hypotenuse of this right triangle. So we have one side, the other side, the hypotenuse comes across. You can think of the hypotenuse as the resultant. If you had added these two vectors together, v1 would be what you would get. And you'll notice this little inside angle is 22 degrees, because remember, when it's written as 22 degrees north of east, it means start east, move north, 22 degrees. So if we start east, swing north, this angle is the 22-degree angle. So you have to draw the picture. Otherwise, you won't know which one is opposite and which one's adjacent. Okay, so what do? We start with sine. Why do we start with sine? Because it's my favorite trig function. So sine theta is opposite divided by hypotenuse. Opposite over hypotenuse. So we'll look at this diagram to figure out what is theta, which side is the opposite, and which side is the hypotenuse. Theta is this 22-degree angle. 22 degrees is theta. So if this is theta, the side opposite is v1y. So v sub 1y. Remember, the 1 and the y are subscripts, so they sit below the line and they're a little smaller. So we can plug, and the hypotenuse is just v1. So we plug that into our equation. Remember, you write the equation down, then you plug in. So it's sine, now instead of theta, it's 22 degrees. Opposite is v1y. We don't know what that is, but we're going to write down the symbol. And the hypotenuse is v1. Well, we know v1 is 160 meters per second. So I fill it in. All right, now what? Well, we have a fraction on the right-hand side, so we need to get rid of the denominator. To do that, we multiply both sides by 160 meters per second. Multiply both sides by 160 meters per second, so it pops up on the left and disappears on the right. And on the right, we're left with a v sub 1y. So the 1 and the y again are subscripts. And now you do the math. You punch in, make sure your calculator is in degree mode. And if you don't know how to do that, bring it to class and ask me, and I will help you. So punch in 160 sine 22, hit enter. And you should get 59.937. And then we know it's meters per second because that's what all the V's were given in. How do we know it points north and goes up? Because of the picture. And because we were given north as one of the directions. So we know we have a vector going north and a vector going east, and they add up together to give us this. All right. So if we've used sine, now we have to use cosine. So cosine is adjacent divided by hypotenuse. So theta is still 22 degrees, but the adjacent side is V1x. So cosine of 22 degrees is going to be equal to V with a 1 and an x as the subscript, and then divided by 160 meters per second. You need to get that 160 out of the denominator. How do we do that? We cross multiply. So 160 meters per second multiplied by, whoops, there is a mistake. I see it. That should say cosine. So it's the cosine of 22 degrees. I am sorry about that. It's a typo. So 160 meters per second times the cosine of 22 degrees equals V1x. And remember, the 1 and the x are subscripts. So you punch in 160 and then multiply it by cosine 22, hit enter, and you should get 148.349 meters per second. We know it points east because east was part of the direction we were given. And so that's V1x. So we've resolved into components. Now we need to do the same thing for the second vector. So our second vector is 120 meters per second at 67 degrees north of west. That just means I need, west is over here pointing left. I don't know, it got cut off, but north goes up. So we need a vector going west. Here we are, V2x. Added to that, we need a vector going north. Here it is, V2y. And then the resultant is this black line, that's V2. And this little angle in the corner is 67 degrees. By the way, you could go up and then over and it would still all work out, but I almost always like to move in the x direction and then up or down. Again, sine is my favorite trig function. So sine is opposite over hypotenuse. Opposite will be V2y. And the hypotenuse is just V2, but we know what that is. It's 120 meters per second, and the angle is this 67 degrees here in the corner. We have 120 meters per second in the denominator. We need to get rid of it, so we multiply both sides by it. So you have 120 meters per second times the sine of 67 degrees. That will give you V2 in the y direction. And when you do the math, punch in 120 times sine 67 and enter, you should get 110.461 meters per second. And we know it points north because north was our vertical direction from the original statement. We need to do the same thing with cosine. So cosine is adjacent divided by hypotenuse. Adjacent would be V2x. So cosine of 67 degrees is V2x divided by 120 meters per second. You need to cross multiply, so multiply both sides by 120 to get it out of the denominator. And then you punch in 120 times the cosine of 67 and hit enter. And if you are in degree mode, you should get 46.887 meters per second, and it goes west because west is the horizontal direction that we were given. So now we need to find the total horizontal component. So that's easy. You add up V1x and V2x to find V total x. But when you do this, you need to pick a direction to be positive. Because V2x goes west and V1x went east, I arbitrarily decided to let east equal positive. Most people pick east to be positive, but you also, if you have an east and a west, sometimes people will pick whichever direction has the bigger number. But I made east the positive direction. So we know that V total x is equal to V1x plus V2x. And again, the t and the x and the 1 and the x and the 2 and the x are subscripts. They come smaller and below the line. So V total X is going to equal V1X. It went east, so it's a positive number. And V2X goes west, so I'll write it in as this value, but I'm going to have to make it negative. So V total X is 148.35 meters per second minus 46.89 meters per second. The minus sign is there because V total in the X direction points west. And you can do the arithmetic and you find that V total in the X direction is 101.46 meters per second. It is a positive number, so I know it points east. If the answer had been negative, it would point west. All right. We found V total in the X direction. We need to find V total in the Y direction. So V total Y is V1Y plus V2Y. The vertical, I had to pick a direction for positive. I picked north. Partly that was because they both went north. So V1Y is 59.94 meters per second and V2Y is 110.46. And when you add them together, you get 170.40 meters per second. It is a positive number, so we know it goes north. We are getting close to the answer. So to find the resultant, we need to draw a picture. We draw because our vectors went north and east, my little sketch is going to go north and east. So V total in the X direction went east, I drew it in. V total in the Y direction went north, I drew it in. And V total then is this black dashed arrow. And theta is, I picked to be this angle here in the left-hand corner. So V total in the X direction, to find that, you need to remember the Pythagorean theorem. A squared plus B squared equals C squared. So C is going to equal the square root of those two. Remember that square root is the same thing as raising something to the 1/2 power. So we're really taking the square root. So we don't have A's and B's and C's, we have V's. So C was the hypotenuse, okay, that's V total. A was one of the legs. It doesn't matter if you call it V total X or V total Y, it won't make any difference. So V total X squared plus V total Y squared, raise it to the 1/2 power. Now we can plug in our numbers. So V total will equal 101.46 meters per second. Notice I write it in parentheses and then put the little 2 for squaring. And then plus V total in the Y direction was 170.4 meters per second, and you have to square it. And again, be careful, make sure you use parentheses so you remember your squaring. And then that whole thing added together, you have to take the square root of it, raise it to the 1/2 power. So I got 39,330.29 meters squared per second squared. And we still have to take the square root of it. And when we did, I got 198.3 meters per second. A word of warning. Some of you have calculators that it's really easy to just punch all this in at one time and hit enter and hope you get my answer. You need to be really careful about your order of operations because we're multiplying, well, we're squaring and then adding and then taking a square root. So that's 3 things. You need to be careful. If you can punch it in and get the same answer I got, yay. But if you don't get the same answer, then you need to probably go back and break it up into smaller steps and write intermediate steps down. Write some of the answers down, just like I went ahead and squared these and added them together. I combined, I guess really 3 steps. Square the first one, square the second one, and then add them to get this large number. If I were prone to mistakes, I'd probably break it down into a few more steps. All right, almost finished. All we need is the angle. So bear in mind, we want to look at our drawing. To find the angle, you need to use trig. My favorite trig function is sine. Sine is opposite over hypotenuse. So if this is the angle theta over here in the corner, opposite will be v total in the y direction and hypotenuse will be v total. So I am going to plug those numbers in. Sine theta is going to be v total y divided by v total. So v total y is 170.4 meters per second. V total, well, we just found that, 198.3 meters per second. When you do the division, you end up with 0.859304. But we need to know what angle is that. All right, so to find the angle, this is equal to the sine, but to get the angle, you have to take the inverse sine function. So you would punch in to your calculator either the INV button or the second function button, depending on the calculator. And then you would punch in sine. And then you would punch in 0.859304, and then you would hit enter. And you should then have 59.238. So to remind you, you would have to first punch in either second function or INV for inverse. Then punch the sine button. Then punch in 0.859304 and then hit enter. If you can't do this, then ask me for help. I will be glad to show you on your calculator. But you need to be able to take the value for sine and come up with the actual angle. So we're almost there, 59.238. Which way does it point? What's this angle right here in the left-hand corner? So it would be north of east because we have to start east, move north, 59.238 degrees. And so our answer is, our resultant is 198.3 meters per second at 59.2 degrees north of east. And that will stop video 2. We'll do projectile motion in video 3.